All right, so let's go on to number 2. In number 2, I've got x-intercepts 1, 0, and that's a double root. And -3, 0 is a double root. And I have a y-intercept of 0, 9. And I had a relative max of -1, 16. So, and you can also tell the degree and leading coefficient and your end behavior. So let's look at this one. What was the degree on this one? Those of you that did a number 2 here, that you did problem 2. 4. The degree is 4, and the leading coefficient is 1, so it should end up with an up, right? This should end up with an up. So I have 2, 4, 6, 8. Here's where 0, 9 is. I had -1, 16. So here's what this one looked like. Did we get it if you had problem 2? All right, on problem 3, I have x-intercepts of 4, 0, -1, 0, -2, 0. I had a y-intercept of 0, -4. And on this one, I had a relative max of -1.52, 0.69. And I had a relative minimum of 2.19, -12.1. Think about your end behavior. The degree is 3. My leading coefficient is positive. So it comes up. Whoops, where's my y-intercept? 2, 4. There we go. So then what you're doing is you are piecing together end behavior, degree, leading coefficient, x-intercepts, y-intercept, relative max and mins. Is that making a little bit more sense than yesterday?
Yeah.
That's all I'm hoping. Yeah.
How do you find the relative min and max on the Inspire?
Okay, so are you okay with getting a graph on the graphing calculator? Okay, what you're going to do is you're going to press menu. Okay, those of you on the Nspires. Okay, if you have a TI Nspire, if you can get the graph on, then make sure you play with your window. If you can't see the whole curve, then you're going to have to play with your window first. So on the Nspires, let's first talk about window. You press menu, and then I think number 4 is the window. And then you do number 1 that says something like window settings. And what you have to figure out is X min is, do I need to move it left? X max is, do I need to move it to the right? Y min is, do I need to lower the graph to see what's down below? And Y max is adjust above. So once you have a good looking window that you can see all the curves and all the parts, then what you do to find the min and max is you press menu. Number 6 is the button analyze. and then you should see min and max. What you do is you have your little mouse pad, I guess what you call it, your little arrows in the middle. All you do is shift a little to the left, tap it, a little to the right, tap it, and then your minimum or maximum, it'll come up for you. Do you see it?
Yeah.
Okay.
I see the minimum max button.
Okay, so press whichever one you want to find first. Okay.
Oh.
Yeah, and so you tap a little to the left, and then a little to the right. No, that's not the minimum. Yeah. So try it again. Press menu. Number 6. Do minimum. Just press a 2. Now slide it a little further to the left. A little more. Yeah, not that far. There you go. Now tap. And then move it a little bit to the right using this inside part. There you go. No, you got to get to the right of it. Now tap it. Now it tells you. And you can pull that up. Does that make sense?
Yeah.
Okay, let's try number 4. For those of you that did this one, and if you didn't do it, let's get them down now. So the x-intercept was -2, 0. Now that one's a double root. What should you expect on a graph at a double root?
Bounce off the show.
Good job, a bounce off. Okay, that's going to be a bounce off. I have a y-intercept of 0, -12. All right, so this one was interesting. I had a lot of stuff here. So I've got a -2, a 1, a 3, and I'm going to go by 4s to squeeze this in. Okay, I'm going to go by 4s. So then I had a relative max at 2.22, 16.95, and I had a relative minimum of -0.22, -12.45. For those of you that had problem 4, are you matching me? Yes? Good. All right, so let's plot some of this. I had 0, -12 is my y-intercept. 2.2, 16.95 is a relative max. And then do you see that relative min is just a teeny tiny bit below the y-intercept. Now, what's the degree in number 4? 4. So this is either up, or down. My leading coefficient is negative, so what should I anticipate for end behavior? Down. So this is coming from below. Now, was there also a relative max at the -2, 0? Let me see. Yeah. So I also had a relative max at -2, 0. This is fantastic. This is like super cool. Super cool. All right, so if you look at the x-intercepts, what can you conclude is happening? All right, if the exponent is even, the graph bounces off the x-axis. If the exponent is odd, the graph crosses through. Now, I was asked a really good question. What about an x, something being cubed? It is going to cross through, but it's going to be a little bit flatter because of that exponent. So now, let's take it a step further. Without graphing, what can you tell about the x-intercepts? In y equals x plus 2 times x minus 3 squared. What should we anticipate happens at each x-intercept? So at negative 2, 0, what happens? It's not going to bounce at negative 2, 0 because I only have one of those, right? So this is going to cross through. And then the 3, 0, that bounces off the x-axis. So the big idea is when you have an even root, okay? We've only looked at double roots, but I could have a quantity to the 4th power, to the 6th power, to the 8th power. Those will all be bounce-offs. So in letter A here, it says write a possible equation for each of the following. So here's the deal. At x equals negative 4, I know that the x-intercept crosses through. So that tells me I have an x plus 4 to the 1st power. At x equals 2, it bounces off. So that means I have x minus 2 squared. In order to write the equation, do you see there's a dot right here at negative 3, 5? So we're going to use negative 3, 5 to find the a value. So I'm going to pause a moment, and I want to give you an opportunity to find a and then finish off the equation. Now I want you to also notice the end behavior. Do you see it's a down up? If it's a down up, what type of exponent should it have, even or odd? If it's a down up. No, evens are up, up, or down, downs. So when you have one of each, I'm talking about the end behavior. It's a down up, so that should be odd. Well, look, I have an x plus 4 and an x minus 2 squared. That's x cubed, right? So I have an odd degree. Now, because it's down up, should I anticipate a is positive or negative with down up? Positive, because if it reverses up down, that's negative. So if it's up up, the leading coefficient's positive. Down down, it's even exponent but a negative coefficient. Down up is odd exponent, positive leading coefficient. Up down, odd degree but negative leading coefficient. So I should expect a to be positive. So here we go. I'm going to go 5 equals a times the quantity, negative 3 plus 4, negative 3 minus 2 squared. Now that's negative 5 squared, which is 25. So, Drew, what did you get for A, or what can you get for A now?
5.
Is 25 times 5 equal to 5? No.
100.
Is 25 times 100 equal to 5? So what, okay, let's back it up since we're having some trouble there. What would you do to both sides of the equation to solve for A? Divide by 25. So what's A?
1/5.
1/5. There we go. So you're going to get y equals 1/5 x plus 4 times x minus 2 squared. All right, let's take a look at letter B. So what I want you to do is I want you to identify your x-intercepts. Think about whether it's a double root or a single root, and then try to write the factors. And on this one, do you see I made a dot at 3, -6? So try letter B, and if you're a fast worker, go on to C. Let's see how far you can get. All right, I'm going to go ahead and start this. I have an x-intercept at 0, so it crosses through, and at x equals 5, it bounces off. So I'm going to write y equals ax. Now, I don't typically leave x minus 0. Okay, it's okay to start with x minus 0, but then tidy that up to an x. And then x minus 5 squared. Then I'm going to use this point and say -6 equals a times 3 minus 5 squared. -2 squared is +4. Dividing by 12, a is -1/2. So you should get y equals -1/2 x. Whoops. Times x minus 5 squared. And if you see the end behavior, it's an up-down. I have x cubed with a negative leading coefficient. All right, give me thumbs up, out, or down. If you were here yesterday, how does this feel? All right, okay. So letter C. At x equals -2, it bounces off. At x is 1, it crosses through. And at x is 5, it's going to cross through. This is an up. So what degree should it be? Even. And is it a positive leading coefficient or negative? Positive, because it's up. So I'm getting y equals a, the quantity, x plus 2 squared, x minus 1, x minus 5. Stop and check yourself. X squared x, that's degree 4. That's what I should anticipate. All right, I've got a dot here at 1, 0. So let's do 0. Ooh, I can't use that one, can I? I can't use an x-intercept. Okay. You can't use an x-intercept because that's one of our factors. Here was my other dot. I had 0, 2. So I'm going to say 2 equals a times 2 squared times -1 times -5. 4 times 5 is 20a. So a is 1/10. So y equals 1/10 x plus 2 squared, x minus 1, x minus 5. All right, we have a vocabulary term. It's called multiplicity. Multiplicity is the number of times a root repeats. So we've been calling it a double root. Well, the double root is really multiplicity 2. So let's take a look at this graph to the right. My x-intercepts are -4, 0, 3, 0, and 5, 0. My y-intercept is 0, 180. Do I have any bounce-offs? Where do you see an x-intercept bouncing off? You don't, right? So there's no bounce-offs. So if I want to write the equation, I'm going to use y equals a times x plus 4 times x minus 3 times x minus 5. I'm going to pause, and you can use the y-intercept. And go determine the a value. So, Emma, because this is a down-up, what degree is the exponent? Not the leading coefficient. I'm asking you, is it even or odd?
Oh, odd.
It's odd, okay? So, and think about it like this. This just occurred to me. Even goes the same, up, up, or down, down. Odd is one of each. I don't know if that helps. Now, if it's a down, up, Avery, would that be a positive coefficient or a negative coefficient if it's down, up? Positive, okay? Down, up is positive. Negative is up, down, okay? So here we go. I have 180 equals a times 4 times -3 times -5. So I'm getting a is 3. So there's your equation. Now the word extrema means the local or relative max and min and any absolute max and mins, or global. So if I take a look at the picture, I've already found them for you, okay? So, and again, I'm going to just switch it up. You can use relative or local. Relative or local. And I'm going to just keep changing it so that we get used to either. So there's a local max of -1.395, comma 219.649. There's a local minimum at 4.062, -24.093. There's no absolute extrema because it goes shooting up to infinity and shooting down to negative infinity. So we're going to review what we did yesterday. Where is the graph increasing? You look at a graph from left to right. So we did this yesterday. So this is our second time through it. You look at a graph from left to right, and increasing is what x values describe where the graph is rising. So it's rising from the left until it hits an x value of -1.395. Then it falls, that's where the graph is decreasing, and we describe the x values. And then at this local minimum, the graph is rising again. So let's write these down using the x coordinates. So this is increasing from -infinity to -1.395. Then it goes and it decreases. Then it turns, and we use the U symbol. Now this negative infinity, okay, this negative infinity is not this negative infinity. It's this negative infinity going to the left, okay? Then where is the graph positive? The graph is positive between -4 and 3, and then again 5 to infinity. Where is the graph negative? It's negative from -infinity to -4 and then again between 3 and 5. All right, what questions can I answer or clarify about increasing, decreasing, where the graph is positive or negative? We use X values to describe those. All right, here's a launch question. The Mathmericaland Carnival Company has decided to build a new roller coaster to use at this year's county fair. The new coaster will have a very special feature. Part of the ride will be underground. The designers will use polynomial functions to describe different pieces of the track. Part of the design is shown below. Your task is to guess a possible equation to represent the portion of the track. So here's the deal. We're actually, just because of time, we're not going to do this. But if I ignore the A value, can you tell it's crossing through at 0, it's bouncing off at 2, and crossing through at 3. So this would give us, without knowing the A value, a decent polynomial. All right, so now we're going to use that new vocabulary, multiplicity. So when it says identify the root is the 0 or the x-intercept. So each root, I'm going to say, is x equals -2, and it has multiplicity 2. I have x equals 1, it has multiplicity 3. X equals 4 has multiplicity 1. Now I'm going to show you what's happening when you get a third, okay? When you get that multiplicity 3. So your x-intercepts are -2, 0, 1, 0, 4, 0. The y-intercept, this one is a little bit harder. So that's 0, 2. The leading coefficient, what's the leading coefficient on this one? It is it 1/8? Well, look right, yeah, you're right. Okay, so the leading coefficient is 1/8, and then what's the degree?
4, no, 5, no,
6. Good counting there. So look, it is 6, because look, I have 2, 3, that's 5 plus 1 is 6. Okay, so if it has a positive leading coefficient, degree 6, this is going to be an up. Now before I sketch it, I need to go find the relative extrema. So grab your graphing calculators and go enter this original function. Y equals 1/8 x plus 2 squared, x minus 1 cubed times x minus 4. So I'm getting a local or relative max at negative 0. I can't read my own handwriting. Is it 886? 85. I can't read my handwriting. Anybody help me? What was the local max? Negative 0.8. And what came after the 8? It's comma 5.085, but I now can't read my handwriting. Would you get, Mia? Is it negative 0.886?
Yeah, negative 0.886.
Okay, good. All right, couldn't read my writing. Local min at 3.386, negative 30.243. So what I want you to notice on the coordinate grid, I didn't put any ticks on the y-axis because sometimes you've got to go by tens, sometimes by 25, sometimes by 50s or 100, depending on how big it's going to go. So I'm going to go by tens. Or no, I'm going to go by fives. 5, 10, 10. There we go. Okay, so now let's plot all this good stuff on here. So I have a negative 2, 0, a 1, 0, 4, 0. I have 0, 2. And then I have negative 0.866 and a little more than 5 is a max. And this is, be careful, I have a bounce off at 2, negative 2. Now, at x is 1, it flattens a little bit. So I wanted to answer the question that I think it was Cal asked me towards the beginning, is what happens when you have multiplicity 3? It doesn't cross through like it does at the x is 4. It does cross through, but it's flattening just a little bit. I'll come right back to this. Whoops, that's the wrong thing.